Dear student, in previous class I was discussing regarding the what are the standard test signals which are widely useful for testing the performance of the control system, and also the what is the time response CFT of a first order system. In today's class I'm going to discuss the examples on first order system. In this particular example, here the first order closed loop transfer function is given. Here the transfer function is given directly and ask you to find out the determine the time constant and the response of the system for the unit step input. Here ask you to find out the C of t value, and also the time constant t of the first order system. Here the C of s divided by R of s is given and ask you to find out the time constant and also the C of t for the unit step input. Oh, therefore, the given CLT of is equal to C of s divided by R of s is equal to 1 divided by s plus 4. Therefore, the C of s is the output in S domain, R of s is the input in S domain. Therefore, this issue is called as a closed loop transfer function. This is given 1 by s plus 4. Now, I want to calculate first C of s output in S domain is equal to input R of s into this is the transfer function, input into transfer function. For unit step input, R of s is equal to 1 by fs. If it is input of the system is unit step input, then R of t is equal to 1. If I take the Laplace transform of the R of t, then R of s is equal to, for unit step, R of t is equal to 1. If I take the Laplace transform of R of t, then it is equal to 1 by s. So therefore the R of s is equal to 1 by s. So now C of s is equal to 1 by s. So into 1 divided by s plus 4 and divided by s plus 4 by expanding C of s in partial fraction. But C of s is equal to a by s plus b by s plus 4. Now the C, if I expand this is the C of s is equal to a by s plus b by s plus 4. Now what is the value of C of s? Now C of s is equal to now C of s is the nothing but the, you have to substitute C of s value. So C of s value is equal to, what is C of s value? C of s is equal to 1 by s into s plus 4 in left hand side, right hand side, a divided by s plus b by s plus 4. B by s plus 4. Now if I take the LCM, then s into s plus 4 is the LCM. Then here a into s plus 4 plus b into s. So now this is equal to s into s plus 4. Now this is the equation. Now this is equal to what? Now this is equal to gets cancelled. Here the both the terms can cancel. 1 is equal to a into s plus 4a into s plus 4 a into s plus 4 plus bs. So now if I now what is the value of here? If I simplification as plus a into 4 or 4a plus bs. So now this is equal to here also so here also so if I take the s outside, and then what is the a plus b into s. So by comparing the coefficient of like term, in this particular equation. This is the equation by comparing to find the values of A and B by comparing the coefficients like term. I want to find the A and B. Comparing the coefficient of like term. This is the constant. This is a constant. So therefore 4A is equal to, if I can compare the left hand side constant with the right hand side constant. So then 4A is equal to 1. No, the 4A is equal to 1. No, therefore A is equal to 1 by 4. Similarly, if I comparing the coefficient of S, so in both the sides, so the coefficient of S in right hand side is A plus B. Left hand side is the coefficient of S in right hand side is A plus B. Right hand side is 0. Therefore, now what is the B value? B value is equal to minus A. Now what is the value? C is equal to minus of A value is 1 by 4. Therefore, they substitute this value in partial fraction equation. Then what is the B value and value? Then C of S is equal to 0.25 divided by S. So minus, this is also minus 0.25 divided by S plus 4. Now by taking inverse Laplace transform, by taking inverse Laplace transform, by taking inverse Laplace transform, what is the value of, by taking inverse Laplace transform of C of S is equal to C of T, the Laplace transform of 0.25, the Laplace transform of 1 by S is 1, no, minus 0.2 as it is. So Laplace transform of 1 by Laplace transform of inverse Laplace transform of 1 is equal to, what is the, this is equal to minus 4t, because the Laplace transform of inverse Laplace transform of 1 by S plus A is equal to e power minus at. By using this relation, I have written this. So now this is the response of the first order system. Given example. In this particular example, directly given the transfer functions. In another example, they are going to give the differential equation and ask you to find out the C of t, time response of the particular system. Usually, the first example, they are directly giving the transfer function. So next exam, they are going to give the differential equation, and differential is converted into closed loop transfer function, and then find the C of t. Now this is the C of t value. Now this is the C of t. So C of t is equal to 0.25 minus 0.25 e power minus 4t. E power minus t. Now this is the required time response of the system. Now this is called as a CSS of t, and this is called as a, now this term is called as the CT of t, transient response. So steady state response is the final response of the system. Transient response is the in order to the response of the system, both are part of the time response. So the CT of transient response is the responses from initial state to the final until reaching the final state. that particular response is called as a transient response. So now what is the ask you to find out the time constant. So therefore t is equal to the time constant. To find out the time constant, so the time constant t is equal to what is the t value here? If I compare this with the standard equation, no, e power minus t by t, then what is the 1 over t? 1 over 1 by t is equal to 4. Therefore, t is equal to 1 by 4. Oh, the 1 by 4 is the time constant of this particular system. Oh, in the next example, so I'm going to consider the another examples on this first order system. So in that case, in that particular problem, directly they are going to give directly the differential equation of the system, and from that we need to find out the transfer function. Find out the transfer function and find the time response of the system. In this particular example, the system is represented by the differential equation. This differential equation is converted into the transfer function, and then find the C of t. This is the another type of problem. Another type of problem usually asking in the examination. So the differential equations of the system represented by the system is the differential equation. The system represented by the is differential equation. Now by taking Laplace transform, the differential equation, Laplace transform of dy dt is equal to s. So if I take the Laplace transform, f of t become f of s. So here also f of s. So phi into t. Now Laplace transform of t is equal to 1 by s square root. 1 by s square root. If I take the f of s outside, then f of s outside, then what will be the output? Then what will be the, if I take the outside, then if f of s is equal to, now what is the f of s? F of s is equal to 5 divided by s square into 1 plus 0.5 into s. So now expanding f of s into the partial fraction method, we get f of s is equal to, what is the f of s? F of s is equal to, what is f of s is equal to by s plus b by s square plus c by 1 plus 0.5 into s. Now this is the, now what is the value of f of s? The f of s is equal to, now substitute. Now what is the value of f of s is equal to, this is equal to, f of s is equal to, here I have to substitute f of s value. F of s value is equal to 5 divided by square. This is equal to a by s plus b by s square plus c by 1 plus 0.5 into s. 0.5, 1 divided by c by 1 plus 0.5 s. Now this is equal to 5 by s square into 1 plus 0.5 s is equal to s square into 1 plus 0.5 s is the LCM. Then 5 into, what is the 5 into, now this is the a into, no, not 5, a into, now a into s into, now a is s into 1 plus 0.5, so plus b into 1 plus 0.5, yes, so plus c into s square. Now this gets cancelled. Now what is 5 is equal to a into s into 1 plus 0.5 plus b into 1 plus 0.5 s plus c into s squared. Now this is the equation. To find the ABC value by comparing, to find ABC values a comma b comma coefficient ABC, comparing coefficient of like terms, comparing coefficients of like term. B is equal to 5. If I compare the constant of the left hand side with the constant of the right hand side, then b is equal to 5. Here there is a 5 is a constant. Now this is also constant, b into 1, and this is also constant. Then b is equal to, now similarly, if I comparing the variables a plus b, coefficient of s, so then a plus 0.5b into 0. Coefficient of s, if I compare the coefficient of s, so then what will be the, now this is the, now what is the a is equal to minus 0.5, b is equal to 5, therefore 0.25, b is equal to, similarly c coefficient of s square. If I compare the coefficient of s square, and then c is equal to 0.5, a plus c is equal to 0. Now c is equal to minus 0.5a, therefore c is equal to minus into minus 2.5 is equal to plus 2.5 plus 2.5 a 0.5 into minus 0.5, c is equal to minus 0.5 into, therefore 1.25 minus 1.25. Now substitute these values in original partial fraction equation, and then what will be the c of s? So c of s is equal to, now c of s is equal to minus 2.5 divided by s, substitute plus 5 by s square plus c value is 1.25 s into 1 plus 0.5 s. By taking, now this is f of s, by taking inverse Laplace transform, f of t is equal to minus 2.5 into 1, inverse Laplace transform of 1 by s is equal to, now similarly plus 5 into t plus 1.25 e4 minus 0.5 into t. Now this is the desired time response of the system, represented in the form of not, this is 2t minus 2t, the form of differential equation. And the next session I'm going to discuss regarding the important concept of the time response of feedback control system is the second order system. The first order usually will ask you to derive the time response of the, is a frequently asking question. is frequency as question is ask you to find out the ask you to derive the time response of the second order system for the unit step input. Thank you for listening.